Hey, Walter Sorrells back with more tips for the knife maker. Today, mounting a 12-inch contact wheel on my Bader belt grinder. So I don't know about you, but when I bought my belt grinder, I bought as many attachments as I could afford at the time, and I really haven't done much to add to them in the 20 years since. Until now. Buying a 12-inch contact wheel from the manufacturer of my Bader belt grinder was something like, I don't remember, but it was like $400 or something if I recall correctly, so I just skipped it at the time. Now, big contact wheels are mostly used for hollow grinding, and I just got used to flat grinding, and I really never felt the need to get a large contact wheel. But recently I decided to remedy that. Sometimes hollow grinding is a nice feature on a knife, and the 8-inch wheel just really doesn't hack it for the size of knives that I make. So I ordered a 12-inch wheel for $129 off of eBay from AMK Tactical. It's just a wheel with bearings, but there's no mount, no axle, nothing. So today I'll show what I had to do to mount it myself. The rationale for selling a wheel without any mounting gear is that every grinder is different. Now, to that point, if you have a different kind of machine, you'll need to do some things differently than I do if you're trying to follow along with me. And you may not want to go quite so elaborate as I did. But this will show you one basic way of solving the problem of mounting a contact wheel. So, the old 8-inch wheel that I have will serve as a model. It's got an arm that slides into a shoe on the grinder, then of course a shaft for the bearings, and the wheel to mount onto. So I'll be doing something kind of similar. This has some kind of nice seal bearing thing that I'm not going to be able to duplicate, but I'll do my best. Now, some people mount contact wheels on shafts made from threaded rod, but I wanted something that would be really durable and precise, so I'll be turning my shaft on a lathe. If the threads on the rod that you use as your axle start to crush, you could get vibration and chatter, and with the amount of inertia that's locked up in a big old wheel like this, you could really end up with something fairly nasty happening eventually. So basically the part will consist of the shaft itself, a standoff or flange so that the wheel is safely offset from the arm, and on the other side a shorter little shaft that will pass through the arm and attach it to the machine. The arm is just a chunk of 1 1/4 square bar. It's probably gilding the lily, but I'll surface grind the interior face of the arm, and that way the shaft flange will mate really nice and tight and square to the arm, and there's no danger of it shifting around or being out of true. I'm using 01 tool steel here for the shaft, though I don't think that's really critical. I'll chuck it up, then face the shaft. I'm turning the shaft 1.995 inches long, which is a hair longer than it needs to be. In other words, it'll extend a little bit beyond the bearings of the wheel. Now, being the piss poor machinist that I am, I'm big on better safe than sorry type measurements, and I'll adjust it backwards once everything's put together. The bearings are 1/2 inch ID, so I'll turn this down to about 500 thousandths. First, I'll cut fairly aggressively, as you can see from the blue chip that's forming here. Once I get closer to the final dimensions, I'll start taking much more conservative cuts. I switch from my cheapo electronic calipers to a micrometer as I get down to the last 10th thou or so. It's not just that the calipers are less accurate, though they are, but also it's easier to read the micrometer from this position, and that's kind of the determining factor as to why I did it. As I'm creeping up on the final dimensions, I'll try it out a couple times to see if it goes on. I know it'll fit at 500 thou. I've already run a precision ground rod through the center of those bearings, but it might fit at 501 or 5015 or something, so I'd rather get it tighter if I can. Finally, there it is, a really nice tight friction fit, and as I figured, it was actually a little tiny bit above 500 thou. Now I'll drill a 17/64 inch hole, which I'll later tap for a 5/16 18 thread to receive the end cap that I'll be fabricating. Like I said, I've also turned it a little over long. According to the manufacturer, you want the external retaining feature to be 5 thou past contact with the bearing. That way you'll have a tiny bit of clearance and nothing's going to bump up against the bearings. I'll fabricate an end cap, but you could use a nut and a washer. Anyway, the main point here is you don't want to squash the bearing by tightening a nut against it. So I've measured the excess and then used my cutoff tool to chop off just enough to leave my extra 5 thou. Now I'll turn it around and more or less repeat the exact same process. Only in this case the shaft will be a little shorter. It's just 1 1/4 inches long, and that's just enough to get it through the arm. And here I'm boring a 1/2 inch hole for the shaft mount onto the arm. I'm doing that on my Tormach CNC machine, which will give me a nice clean bore to this hole, much more accurate than if I did it with a drill. Now for every machinist's favorite task, tapping. If I had a nice spiral flute tap, I'd use power to tap this hole, but all I've got in this size is this cheap tap from a set I bought at Home Depot a decade or two ago. So I'll chuck it up in my mill to keep everything aligned nicely and then yank it around by hand using a little pressure on the feed lever. I've tried at least 143 different tapping methods for small holes, and so far I haven't found one that I really love. Someday I'm going to invent the unbreakable tap, and then I'll spend the rest of my life riding around in a limo laughing at all the little people. But until then, there's this kind of thing. There we go. So here's the finished shaft. So let's assemble at the anvil and assemble the assembly. Now, I actually didn't have time to make the retaining cap for the shaft, so just for demonstration purposes, I'll use a nut and a washer to test it out. If you do this carefully enough, it should work fine, but I'd rather be a little more certain and do it correctly in the long run. If that washer hangs out too much and deforms a little bit or things move around, it could end up shredding the edge of your bearing, and you really don't want that. And there's the final product after 30 seconds of exhausting assembly work. Hope you came away with some useful information here. Like I always say in these kind of builds, there are a lot of different ways to do these things. There's not one right way. Obviously, everybody doesn't have a lathe, and it's always useful to see how other people solve problems in their shop. So hope this was useful to you. Keep making those knives, guys. See you soon. Thanks for watching, guys. If you feel like you got something out of this video, don't forget to subscribe. Also, click on the link to Patreon for a great way to give back to the channel. Plus, check me out on Instagram, Facebook, Twitter. Links in the description. If you want something sharp and pointy, maybe a gift for yourself or one of the cooler people in your life, check out my Tactics Armory website and pick up one of our tactical or outdoor knives. And finally, if you want to learn to make hamones or Japanese swords, check out WalterSorrellsBlades.com, where you can find videos about how I make hamones, as well as forging, mounting, polishing, and fittings for Japanese swords. Thanks, and see you soon.